Thank you very much. Thank you, Danilo, for organizing this workshop, and thank you all. It's always a pleasure to be here, to participate to the SPAM, and seeing some friends and people working on this very, very interesting topic. Today, the presentation is made by me and Giulio Steyde, which is a PhD student working always in the Politecnico di Milano in this topic. So, the role of the machine learning and deep learning methods and models in monitoring and predicting fetal states in pregnancy. So, I have to move okay, it works. So a brief introduction to what the cardiotocography is, but you are all expert on this point. So we work since many years in the analysis of CTG tracings, CTG signals. These signals were collected in a hospital, which is in Naples, and we tried to classify, to analyze this data through indexes. Some of them are derived from the classical analysis of the CTG signal. So they are associated to the short and long-term variability that are parameters that are used in the clinical evaluation. To this set of parameters, we added frequency domain parameters and nonlinear indexes. So this set of parameters, including all these methods to analyze the CTG signal, were considered together. I don't have to, I have to check my time. So what's the advantage using this kind of parameter? Is that the main advantage is these parameters are physiologically interpretable. So the association between the parameter that you can use in the frequency or in the time domain is related. The result you obtain can be related to some event, to some physiological events that characterize the functioning of the different systems that are involved in the generation of the signal itself. So, we too collected in this year a big, huge database. So numbers are reported here. They are this database called NAPAMI, taken by the Naples, Pavia, and Milano universities that collaborated to the generation, to the collection. Contains CTG recordings. Even in a long intervals, and they are this data have been structured and are now available for the analysis. The strength is that this database is very large and the data are annotated and suitable for artificial intelligence application, and that the quality of the data is good because the database was cleaned by noisy data, and there are even some limitation, mainly due to the privacy constraints in Italy. And about this point, I wish to open a point. I'm looking to Antonia. Open a point inside the SPAM board, because we have a lot of initiatives concerning the collection of the data. The question is, can we organize something? Can we create something that could be shared, that could be a reference for for our work? It was my question this morning, and I think it could be a question that is of interest of all of you, all of us. So this is unreadable, but only to communicate how many parameters we can have, we collect in this database, parameters that are global parameters from time, frequency, and nonlinear domain, but also pregnancy data, parameters related to the state of the mother, which is a bit, which is always present, but is a bit not considered in our analysis. I'm looking to Bill after the discussion today during lunch. So, parameters that are different even for time scale, 1 minute, 3 minutes, longer. So there are some different views in which we can consider them. We started with, Niccolo Pini is here, and is part of this history. We started with the machine learning approaches, so collecting data, extracting from the CTG parameters. Then these three big family of parameters were used to classify, for instance, this is an example, healthy from UGR fetuses, because sometimes the UGR condition is not so clearly identifiable, but through the analysis, but even using this approach, we can not easily, but try to separate the two conditions. In which way? Through machine learning approaches, and machine learning approaches we adopted started from logistic regression, but supervised machine till random forest. That is one of the machine learning method that performs better in this separation. Well, classical machine learning approaches have positive aspects that are summarized in the prose. So feature can be reconducted to physiological mechanism, and this is a very important point, as we have to translate to clinician what we extract, at least in most cases, and having this correspondence helps this procedure. Then averaging reduces, the averaging adopted in the machine learning reduces the sensibility to noise. But the cons are that we do not consider the time evolution. So we lose the concept of time evolution. So averaging can remove information, and the choice of the feature is mainly arbitrary, and no adaptive is not made in an adaptive way. So now, what is the new approach? Is based on the deep learning method. They become very popular. Today, there were a lot of presentation about the deep learning, so this is a hot aspect of our work. Instead of manually computing the feature, the deep neural network, DNN, extracts the information directly from the data. This is an improvement, and sometimes the DNN produce results that are more reliable in respect to other approaches. Not often, but they have this characteristic. What is the the aspect that we don't like, and physicians do, that results are not directly interpretable. We have a problem about explainability. So another point open is, if explainability is a value for the translation, for the evaluation, we have to concentrate on how we can, the explainability can be obtained, and how robust is the explainability level that we can obtain. Other point. So, okay, I'm going in a wrong direction. Two examples of this application. The first is the recognition of fetal behavioral pattern, and the second one, the identification of intrauterine growth restriction. I start with the fetal behavioral patterns. You know that, and the elderly part of this group remember certainly the classification of CTG, fetal trait, in intervals 1F, 2F, 3F, 4F, so the different behavioral patterns that characterize the fetus. Then we move to activity quiet, because these two activities characterize the fetal behavior. This is an example of what is considered quiet, the blue, and the red, what is considered active. The line under the graph with these small signs is associated to the marks that the mother signs about the presentation of the fetal movement, about the fetal movement that she perceives. So automatic identification of fetal erythroblast can facilitate clinician work and improve the reproducibility. So to do this, a model based of 4 steps. This is what we have done. Okay. Huh? Yeah, but that's. Yeah, it's a hidden Markov model. The hidden Markov model starts from data and produce a labeling in quiet and activity. These pseudo labels were used by an untrained deep neural network, and this neural network obtain a classification. This classification is improved by what? By an expert gynecologist that classifies himself the activity and quiet, and the additional knowledge produced by the gynecologist is used to retrain the DNN, producing the final classification. So what is obtained is something like this. This is a trace in which we have in red active sleep, in blue quiet sleep, and the first line is performed by the deep neural network, and the second one is produced by the obstetricians. There are some superimposition which are in the transition zone, basically. So the results, the balance of accuracy, macro F1 score, and the Matthew cross correlation are provide good results. This is comparison between what the model and the obstetrician do. And now Giulio will show how.
I have like 30 seconds. Okay, I'll
No,
be
no,
as
no.
fast as I can.
Sorry.
Yeah, no problem. Okay, as many people said already today, research in this field, but in many other fields, is moving from feature-based machine learning to completely data-driven deep learning without any explicit feature extraction. And here we show some results concerning IUGR identification using fetal heart rate signals. Okay, the thing is fairly easy to just grab as many data as you can and put it inside the deep neural network and make it learn something. But quite often the network can learn all sorts of things, including biases which are not relevant for the clinical application. And so, for example, one of the things that we noticed by just putting all the data inside the network is that there are some differences inside the distribution of the data between IUGR and healthy pregnancies, some of which are not relevant for the network, and we don't want to learn them. One of that is, for example, IUGR cases tend to undergo antepartum CTG recordings quite earlier compared to healthy pregnancies because there was already a suspect of intrauterine growth restriction, so more reason to do more frequent and anticipated analysis. And also another problem that is limited to our data set is that we often don't have reliable annotation on the outcome data. So what we did was basically split the training into parts. During the first, we use the data which are that don't have any annotation at birth, but only the annotation done during pregnancy, which also include small for gestational age fetuses, so not confirmed as intrauterine growth restriction. We call that like the suspect. And then a second database with only pregnancies which were annotated at birth and were definitely intrauterine growth restricted. And also, concerning gestational age, we balanced the data not only according to the classes during training, but also with respect to gestational age. We want equal representation of healthy and growth-restricted fetuses along gestation so that we don't simply learn the bias. For doing that, I'm sorry, there's a lot of information and also some problems with the slide layout, but we use the residual network, which is almost still the state of the art for time series classification until if you want to go from a time series to a final classification. And during the first step, we made a pre-training using only the suspected intrauterine growth restricted fetuses with the aim of like simply learning features that we suppose will be relevant also for the final classification, which is then performed by cropping the last part of the network, the one that performed this classification, and adding some more layers and doing a second part of the training. And this results in, well, the final results are quite satisfactory. I believe they are more or less in line with what was obtained using machine learning in the work that was cited before, but in this case we have a much larger population, which doesn't include only very clean and selected data, but it's very representative of the general population, at least of the hospital that we have collaboration with. And the next step of our course, of course, as has been said before, explainability. One, it's because we want physicians to trust our model and to understand what the model is doing. Otherwise, it might be a bit, it might seem a bit random, and also as a form of model diagnostic to make sure that what we are learning is actually what we want to learn, and it's not just another bias as the one concerning gestational age. Thank you.
Thank you. Very good.